Hello, I'm Bob Falco, and I want to show you some important health information that relates to using your car, particularly if you're using a gasoline-fueled car. The issue here is that gasoline, to enable it to run your car effectively, has a percentage of benzene in there that appears to be a small percentage, but could in fact, added over time, turn out to be a health hazard for you. Benzene in particular is related to leukemia and some other cancers. But the issue here is that it's part of your daily life and that there are some very simple rules of thumb that can prevent you from building up dangerous amounts of benzene in your system. So moving right along, let's first want to point out to you that the cancer rates in the United States are incredibly high. This is a little cartoon from Newsweek this past October 2012, which shows that 1 in 2 men will develop cancer. 1 in 3 women will develop cancer. And of those, 1 in 4 will actually die from cancer. Now, the largest source of man-made carcinogens, carcinogens are chemicals that give us cancer, comes from gasoline. It's literally 3/4 of the man-made carcinogens, according to the United States Environmental Protection Agency, that are coming from gasoline. Another 1/8 come from diesel fuel, and another 1/8, the remaining 1/8, come from industry and/or utilities. So gasoline is a major culprit in terms of man-made carcinogens. Now, about 1/3 of the cancer risk in the United States is judged to be due to vehicles. This is a 1999 estimate by the EPA again, from their Technology Transfer Network National Air Toxics Assessment. They're saying that roughly 1/3 of the cancer risk is attributable to mobile sources. That works out to basically 14 Americans in 1 million. You say, well, but we have 300 million people in this country, 110 million, and that means there's an additional 4,340 deaths every year because of the fuel that we're using in our cars. Okay, the key, there are a number of components of gasoline that are dangerous. There's benzene, there's toluene, there's xylene, for example. But the most dangerous is benzene. Benzene in the fuel we use is first put in at the refinery. Roughly 1%, actually 1.05% on average, has been put in the United States since about 1993. And now there's a move, as we'll see later in this presentation, to lower that amount to 0.62%. But that move's quite complicated, as we'll show. The other way you get benzene is that it is actually created in the catalytic converter. And we'll show you some of the numbers related to this study. While under ordinary conditions, which we'll also show, catalytic converters actually lower the amount of benzene that comes out the tailpipe. Under some conditions, they increase it. Okay, so the thing here that leads the rest of the conversation is that benzene is a major carcinogen. Benzene produces leukemia. And frighteningly enough, there is no agreed upon lower limit of exposure. Now this slide shows you the incredibly wide range that various regulatory agencies have proposed as limits on the amount of benzene that a human can absorb. And most of these are over one's lifetime. So the health numbers literally on the left-hand side of this bar chart are differ by 100 million times. 100 million times. The European Union is that little red line there, and that's their agreed upon limit of benzene. But regulatory agencies in the United States differ by the amount of bars, literally 1,000 times different, on the right-hand side of this chart. This is from the EPA study in January of 2012. What it really means to you and me is that they don't know where to draw the limit from accurate, well-defined statistical scientific experimentation. It's all over the map. We don't know how dangerous benzene is. We do know it's put into our gasoline. Well, don't we have any estimates of this? And the answer is yes, we do. The EPA sets cancer odds, 1 in 10,000, 1 in 100,000, 1 in a million. Let's see what they are. So this is the EPA's odds. Now, bearing in mind that chart, depending on what organization you're drawing your information from, this could be very, very different. But this is our EPA, our Environmental Protection Agency, and so let's have a look at what they say. Well, here's sort of their basis. They say that if you're exposed to 13 to 45 micrograms, that's millionths of a gram, per cubic meter of air, there is a 1 in 10,000 chance of increasing the number of cancer deaths. Or I should say, the number of cancer deaths per year will increase by 1 in 10,000. Well, over our population base, that's 30,000 deaths a year. If you are exposed to 1.3 to 4.5 micrograms, in other words, a tenth of the above number, then there's a 1 in 100,000 chance of increased cancer deaths. Now, we're down to 3,000 extra deaths a year. And of course, if you divide that by 10 again, 0.13 to 0.45, there's a 1 in a million chance of an additional cancer death, which brings it down to 300 a year. Well, we're going to get some idea of where we stand in this wide range of possibilities in these succeeding slides. Okay, what ways are you exposed to benzene from gasoline, and what amounts are you likely to inhale in those different ways? Well, there are 3 main ways to inhale benzene. The first is when you fill up your tank. When you fill up your tank, you're putting gasoline, a liquid, into a tank that has some other gasoline in there, presumably not too much, and above the gasoline that's in the tank, a vapor forms. That liquid vaporizes, and the particularly strong vapors that come out of the gasoline are benzene, also xylene and toluene. But benzene is a key cancer problem, and we're going to focus on benzene. The other way you get benzene is through burning the fuel, both from what's left in the fuel after it's burned and what gets through the catalytic converter, or what is created in the catalytic converter. We can talk more about that. So tailpipe emissions is the second way. And the third way, which most people don't realize is a very important way, is through leaks in your gas tank filler cap. The EPA estimates that 200 pounds a year of gasoline leaks through the average gasoline filler cap, and we'll see why that's very important for us. Well, let's start first with the refueling. This is an image of a man filling his pickup truck, and we see a little bit of black smoke around him, and that black smoke isn't visible to the normal eye, but it's visible to this very special camera because that camera can only pick up the benzene emissions in the 3 to 3.2 micron wave length range, which we can't see. So we don't see this, but the camera sees it. However, you can actually smell benzene. So if you smell the sweet odor of benzene, you're getting quite a lot of it. You see, the human nose has an odor threshold of 5 milligrams per cubic meter. If you remember in our previous slide, we were talking micrograms being the issue. So thus, if you're smelling the sweet odor of benzene as you fill up, you're being exposed to 1,000 times that determined to give you 1 in 100,000 chances of getting cancer. Now, if you were continuously exposed to this amount, you would have only a 1 in 100. You would have as much as a 1 in 100 chance of getting cancer, of getting leukemia, uncurable leukemia. Okay, so where are we now? We want to look at what the EPA is doing to protect us. What are they doing to protect us? This is something that we have to really begin to understand, because we're led to believe that we are protected from danger by our Environmental Protection Agency. Okay, so since 1993, the EPA has been installing a protection device on the nozzle that you put into your gas tank called a Phase 2 vapor protection system. And that system is not in every gas station or every state even, but it is in very many of them. And it has been shown to be on average only about 60% effective. That means that a very large amount of vapor is still being emitted from your fuel tank as you refill it each time you refill it. Well, after in around 1998, they began to realize this was nearly not good enough, and that they came up with an onboard system called the Onboard Refueling Vapor Recovery System, or the ORVR. It's an interesting system because what it does is, as the vapor comes out of your gas tank, as we see in that sketch in the top of the slide, it goes through another pipe, indicated by the dark curvy lines there, through a carbon canister, an activated charcoal canister that attaches the vapor to the charcoal so that it actually doesn't come out of the filling hole. As you fill up, that canister fills up. But they built them big enough so that they can handle you refilling your full tank. And then when you start your car again, your engine sucks the vapor from the charcoal canister and burns the vapor, the gasoline vapors. A good thing. The issue here, though, is that even though these systems are 98% effective, you are still, as we will show in just a moment, getting more benzene every time you fill up than the protection agencies feel is good for you. So moving right along to that, let's see. Let's say that ORVR, that onboard refueling vapor recovery system, is 98% effective as the EPA suggests it is. What happens then? Are you good? Are you safe? Well, what that actually means is that over the 5 minutes it takes, or estimated take, to fill up your tank, you're going to get 12 parts per million of benzene coming out of the tank into the air by that nozzle. Well, the industrial standard set by OSHA for what they call the short-term exposure limit is 5 parts per million over 15 minutes. Above that, they consider you to be in danger. Well, that's not, as we saw earlier, that's certainly not the only limit that's out there. For example, NIOSH, the industrial standard set by NIOSH for the short-term exposure limit, is only 1 part per million over 15 minutes of benzene. Thus, the amount coming out of your tank with the best protection system that the EPA is enforcing at the moment is 2.5 times the OSHA short-term exposure limit. And it's 12 times the NIOSH short-term exposure limit. Thus, we are by no means out of the woods in terms of being safe from benzene when we fill up. So here are our recommendations on this issue. To avoid the evaporative emissions exposure that could be harmful to you, especially over your lifetime of using gasoline, don't stand over the gas tank when filling it. Go walk around the car. How do you do that? Well, you lock the nozzle open so it's pouring gasoline into your tank and walk away. Go look at the field next to the gas station. Get yourself out of that plume of really poisonous benzene coming out of the tank. Now, if you have children or other family members or anybody in the car, you really should close the doors and windows of your car when filling it, because those fumes are whipped around the car by the winds, etc., and will get inside the car. Children are especially susceptible to benzene issues. So you don't want to get benzene inside your car during the time it takes for you to fill it. Now, you would think that going in the convenience store is probably the most likely thing you would do, but you need to also note, and it probably is, and it's certainly better than staying over the gas tank while you're filling it, but inside those convenience stores, there's much likely to be higher levels of benzene than are safe as well. And those poor attendants and people that work there are exposed to this. That is considered by OSHA to be an occupational safety hazard. We cannot get into that issue in this slideshow, but the convenience store itself is not as safe as you might think it is. Now, we're going to move on to exhaust emissions. What comes out of your tailpipe is also an issue for you when you drive. The three-way catalytic converter does reduce benzene in the normal range of driving. We're going to show you that in some detail in a minute. However, when you accelerate from rest or you're driving at high speeds, that same catalytic converter might produce more benzene than if it wasn't there. Furthermore, as we'll show a few slides ahead, when the catalytic converter is cold, that is, you're just starting your car, or for the first few minutes after you start your car, it doesn't reduce the benzene emissions at all. Okay, so let's have a look at this tailpipe situation. Tailpipes are usually off to the side of the car. Here's a computer simulation of a car and its emission plume. You can see, interestingly enough, that even though you're in the lane behind, to see that car following in the lane, right behind the car in front of you, that exhaust is in fact not going off to the side, but is dead center in front of you, and that's got to do with the wake of the car pulling the exhaust in behind it. So you get a picture just like this one, an instantaneous picture. Now, the question is, where would you want to be? Well, if you're right behind that tailpipe, there's a 1 in 10,000 chance of having an additional cancer if you were there on a long-term basis. So where should you put your car? I show 3 pictures of the cars there. Sort of a half a car length, 1 car length, and 1.5 car lengths and 2.5 car lengths back. Well, the answer is this. Basically, at 2.5 car lengths, you're exposed because of the plume spreading and getting diluted by the ambient air. You're exposed to only 1/36 the amount of benzene as you would be if you were taking in all of that emissions coming out of the tailpipe. So if you stay right behind the vehicle in front of you, your car really is taking in a good portion of that plume, which has concentrations at the level that would give 1 in 10,000 additional chance of getting cancer if you inhaled it regularly. Okay, so what part of this is the catalytic converter playing? Well, on the right, rather, on the left-hand side, you see what the emissions of benzene, and these are in milligrams, okay, per kilometer that the car is moving over at different versus certain speeds. These speeds are in kilometers per hour here. You're getting emissions the order of over 100 milligrams. Remember, micrograms turn out to be dangerous. Over 100 milligrams at very low speeds during cold starts, which is sort of the situation. You come out of your garage, you go down to the corner light, there's a couple of other folks down there going to work, also with cold started cars. You're in that range of benzene because the catalytic converter is not warm enough yet to do any good. And all the way through the driving range, if you're in the cold start situation, even at higher speeds, you're getting a very significant amount of benzene. With the catalytic converter, which is the graph on the right-hand side, now with that catalytic converter warmed up, the benzene level goes way down, except at low speeds and at high speeds. And what this graph actually shows is that at high speeds there's more benzene coming out of the catalytic converter than would come out if it wasn't there, which is basically the graph on the right-hand side. So, cold starting is an issue here in terms of tailpipe emissions. When your car is cold started, you are really driving behind one, or you're driving behind one that's just been started. The catalytic converter is not removing the benzene basically at all. In this condition, the curve on the left shows that the amount of benzene coming out of that tailpipe is very, very high, literally at all speeds. So when in city driving particularly, you're on the road along with your neighbors, and you're going through lots of lights, getting out of town or just to get through town, on the way to work, this whole time your car is still warming up. Your conditions for benzene are very bad. They're way over the limits that OSHA and NIOSH set. So what do we recommend? Well, between the spreading of the exhaust plume is helping you here. Unfortunately, it keeps the darn emissions in the lane that you're in, but even with that in mind, when you're moving in traffic, try to stay that 2.5 car lengths behind the car in front of you, because basically you're going to get 1/36 of the dosage as if you if you were half a car length behind, and you're sucking in essentially all of those emissions. When stopping for a light, stay at least 1 car length behind the vehicle in front of you. In this way, that acceleration blast of benzene will diffuse to half or a quarter that which it will be if you were right behind the car in front of you. It's still a high dose, but you know we are in trouble using gasoline. We cannot eliminate this. All we can do is reduce it. We can increase our odds that we won't get cancer. If you actually can, you want to change lanes. Find a lane that has no car stopped in front of you. And the other thing you might want to do, literally, is to turn off your AC and your vents when you've stopped at lights, so that you basically are not sucking in any new fumes. Okay, now we're going to move to gas tank cap leaks. This is one you don't think about very much, but again, it turns out to be quite important in a couple of situations. Easy ones for you to do something about. So here's the story. About 200 pounds of gasoline leaks from the average American car's gas tank through the gas cap per year. It's about 25 gallons coming out as vapor leaking through the gas cap. And a very large fraction of that, because the most volatile part of the gasoline is the benzene, is thus benzene. Now, the really biggest problem here is that this leaky gas is going to collect in your garage overnight. So when you get into the garage in the morning, you're going to get one good dose of benzene. But perhaps worse is if you have an attached garage, it'll get into your house. So recommendations here are really quite simple. Check the tightness of your gas cap. If you feel that it's not tight, have someone check if it is leaking. And if it is leaking, of course, change the gas cap. Buy a new gas cap. Many of the state inspection stations make a big effort to check your gas tank leakage for you, but it behooves you to also be sure about the fact that it is on tight and that it's not leaking. Try to air out your garage before entering it. Open your garage doors from inside the house. Leave them open for a minute or two before you have to go into the garage. Go finish your cup of coffee, whatever. Now, you also want to make sure that the garage door leading into your house is well sealed. Always closed and well sealed. And finally, if you can, vent your garage with some kind of exhaust system. That's a good way to cut down the benzene levels that will get into your house from your garage. Now, on all of these issues, it's really important to understand that benzene effects are cumulative. They build up over time. This is really a problem, but we can do nothing about it. Now, let me kind of just show you that this is a well understood problem, by the way. The EPA has for years tried to enforce a lower benzene amount in your gasoline, and they are just starting to now enforce the 0.62% benzene limit. This is a reduction from the 1.05% that's in the average American gas tank now. So it's roughly half, but it's still, even with the 0.62 limit, you're going to be 125% greater than OSHA says is the short-term limit you should be exposed to, and 600% over the NEOSH short-term limit. Furthermore, this does very little to change the exhaust emission picture, for as the Swiss studies show, and the Swiss are the most intensively studied this problem of any country in the world. When you're cold starting, when you're accelerating, and when you're driving at high speed, the benzene emissions can be up to 100 times the steady state rate, and so way, way over the OSHA and NEOSH limits. Now, one final thing that's turned out to be annoying and actually very bad news for some people is that the EPA, to get down to this 0.62% benzene limit, did a little politics and decided to enable refineries to trade benzene credits. The result is that some regions are really suffering at the expense of others. Here's an example. In Oregon, actually the example holds for the Northwest in general, but in Oregon, this is kind of a long slide, but the main message here is that the refineries in Oregon have traded out with the refineries in California, so that they are actually having 2.06% benzene in their gasoline by volume. The second issue is that, according to the Oregon Department of Environmental Quality, benzene contributes almost a quarter of the cancer risk in Portland, for example. And the air monitoring equipment in Eugene is showing the average benzene levels being 10 times the benchmark level believed to spur cancer in humans. And the National Air Toxics Assessment that was established is showing that in Portland there is as much as 40 times the safety limits of benzene in the ambient air. So that trading by the EPA has made people in Oregon and actually Washington State as well at a cancer risk that is really unacceptable. In conclusion, the effects of exposure to benzene are long-term. You're not going to know it by a few short-term exposures. But you must think about these effects as you do think about the effects of smoking over a number of years. It might be 20 years, it might be 30 years, it might be longer. This is going to lead to a much higher rate of leukemia. It will lead to a higher if you have excessive exposure. In the Western world, the proof of the pudding, and particularly in the United States, we have very high rates of leukemia compared to the rest of the world. Of course, we drive more. Very important issue. So, I leave it to you to decide whether to ignore the precautions or to take some of the simple steps which could lead you to have a longer and healthier life. Before leaving this presentation, I want to make sure that you understand that you don't need to use gasoline to run your car. Your car, with very, very small modifications, can actually run better on alcohols like ethanol and methanol, which don't have any benzene in them. They don't have any of the other aromatics like xylene and toluene either. Now, if you want to learn more about this, see the presentations and the references on the following slide. I have a couple of sites, both on YouTube and in SlideShare, where I try to go into some of these things in great detail. However, if you're not interested, please at least understand that over the course of your lifetime, you and your children and your loved ones could be protected to a large extent with from getting early leukemia or getting leukemia at all by taking these really very simple steps of precautionary steps. Thank you. Okay, so some of the references have been compiled by me on YouTube channels, my particular YouTube channel on alternative fuels, and on my SlideShare site. So you'd go to www.slideshare.net/BobFalco to find some more presentations, both voiced over and self-paced ones, and also a list of references that you can so that you can pursue this matter further. Thank you very much.